Hey guys, and welcome back to another video. In this video, we'll be talking about inverse trigonometric functions. Alright, so let's get right into it. Okay, so to begin with, let's start with the unit circle. Okay, so suppose you had the unit circle like that, and let's say I give you some angle theta right there. And I tell you that this point where the terminal side intersects the unit circle is square root of 2 over 2, square root of 2 over 2. Okay, and your job is to find the angle theta. So before it was the other way around, right? I used to give you the angle theta and you have to find the point. But now we're gonna switch it. All right. So how would we even tackle this problem? So we know that on the unit circle we can write each point x, y as cosine theta, sine theta, right? So we can represent a coordinate point in terms of the trig functions. And so this means that from our point, cosine theta is equal to x, which is square root of 2 over 2. And then sine theta is equal to y, which is also square root of 2 over 2. So now you have to find an angle theta that satisfies both of these equations. So there's two ways that you could solve this. So the first way is just by knowing your exact values, right? So if you know your exact values, you can pretty quickly figure out that theta is going to equal pi over 4. Okay, so that's one way to solve it. But suppose you didn't know your exact values, right? So then what would be like the alternate method? So this is when we're going to define our new function, namely the inverse trig function. So for example, if we take the second equation right here, sine theta is equal to square root of 2 over 2, right? What we can do is, I'm going to write this out here. What we can do is you could take inverse sine of both sides, right? Which we denote as sine kind of to the negative 1 power, but like not really. But what this allows us to do is that inverse sine and sine can cancel. So then we're just left with theta. And then this is equal to inverse sine of square root of 2 over 2. Okay, and you could just put this into a calculator, and then you can also easily get pi over 4 equals theta. All right, and just make sure that your calculator's in radian mode though, because you are dealing with radians. But anyway, so that's how you get the that's how you use inverse trig functions. But what if I just gave you sine theta equals square root of 2 over 2, right? Because most of the time you're not going to be given both cases. You're only going to be given like one of them. So let's say you're only given like this one right here. So then, first of all, why is this even a problem? Well, it's because sine of theta equals square root of 2 over 2, that corresponds to two different angle measures, right? That corresponds to this one and then also this one, because both of them, notice, have the same y value, right? So that's why both of these angles, sine of them is equal to square root of 2 over 2. So which one do we know which to pick? Well, that's why we pick the angle known as the principal value of the inverse trig function. And so what the principal value is that for each of the inverse trig functions, we must restrict their range. And we only pick the angle theta that falls within that range. And then we call that the principal value. Okay, so how do we restrict the ranges? So let's just build each of these ranges one by one. So for inverse sine, right? We want to make sure that we can find every angle theta such that it's hit once and only once. So what do I mean by that? So for example, if we go from 0 to pi for inverse sine, then we're only hitting half of the angles, because the y values in the first quadrant are going to be this exact same as the y values in the second quadrant. So that's why 0 to pi is no good. We have repeats. So that's why it's not 0 to pi. But if we go from negative pi over 2 to pi over 2, then notice how we can find an angle theta that maps kind of like that goes to every single y value on the unit circle. So that's why we restrict the domain, or not the domain, the range of inverse sine from negative pi over 2 to pi over 2. All right, because all of the angles in this range will map to every y value exactly once. Okay, So then for inverse cosine, it's a similar argument, except this time we want to map to every x value exactly once. So that's why we're going to go from 0 to pi, because that's hitting every x value once and only once. So that's why we restricted range from 0 to pi for inverse cosine. All right. And then for the other trig values, trig functions, it's pretty much the same thing. So for inverse tangent, so for these other ones, we can think of them in terms of sine and cosine. But for inverse tangent, just think about it in like as the slope, right? So we want to know what is like the range such that we get every single possible slope. Well, if you think about it, if you're going from negative pi over 2 to pi over 2, you're getting every single possible slope that the terminal side could achieve, right? Because the left-hand side from pi over 2 to like 3 pi over 2, that's just the same thing, right? Just in reverse order. So that's why we go from negative pi over 2 to pi over 2. But we don't include the endpoints because at the endpoints, the slope is undefined, right? It's a vertical line, so it's undefined. So we don't include that. So we're going from negative pi over 2 to pi over 2, but not included. So that's why we have the parentheses. And then for the other three trig functions, we simply just think about it in terms of the these three. So for example, secant, we know that's 1 over cosine, right? So inverse secant is 1 over inverse cosine. And so we just want to make sure that inverse cosine isn't equal to 0. So it's the same range as inverse cosine essentially, but we just exclude any points where it might equal 0. So therefore, we know that cosine is equal to 0 at pi over 2. So that's why we exclude pi over 2 from the range of inverse secant. So we go from 0 to pi over 2 union pi over 2 to pi. So it's the same as inverse cosine. It's just that we exclude the pi over 2 because it's undefined there. For inverse cosine, same thing, right? It's the same as sine, but we just exclude where sine is equal to 0. And in this case, sine is equal to 0, well, at 0. So this is why cosine inverse, or cosecant inverse, the range is from negative pi over 2 to 0, a union 0 to pi, pi over 2. Okay. And then cotangent, that's equal to inverse sine over inverse cosine. Or, sorry. It's equal to inverse cosine over inverse sine because it's the reciprocal. So it's equal to inverse cosine over inverse sine. Right? Okay. So therefore, we define the range as from 0 to pi because we want to make sure that sine of inverse sine is defined. It's not 0, right? And so on this interval right here, sine is always non-zero. So that's why we go from 0 to pi. And then we also hit every single possible value for inverse cotangent. All right, so these are the restricted ranges for each of the inverse trig functions, but by no means should you memorize these, right? If you ever need them, just build them like how I just built them from the unit circle, because I feel like it's much more useful to build it from the unit circle than just memorizing this. And if you memorize it, you might also just memorize it wrong, which is never a good thing, right? So yeah, those are the ranges, right? So now let's talk about some common mistakes with inverse trig functions. So first of all, I mentioned that this is like the notation. We say sine to the kind of the -1 power of theta, right? But many students might confuse this as 1 over sine theta, right? Because they see that sine theta is raised to the -1 power, so they hit it reciprocal. This is incorrect, right? This is wrong. The -1 on like the superscript, that is not a power. That's not an exponent, right? That's simply just there to denote that this is like an inverse trig function. That is not like a power, okay? So don't do this. And then the other thing is that some people, like you might see in like your textbook or something, arc sine of theta, that's equal to inverse sine, right? So arc sine and inverse sine are the same thing. And sometimes people might find it more helpful to write it this way because then you avoid this confusion too, where like you think it's like a reciprocal function. So, but yeah, those are like the two main things about inverse trig functions that students might mess up. Okay, so now let's do some example problems. So example 1. So I'm gonna give you 3 sort of equations, and you can find theta for each one. Alright, so go ahead and see if you can find theta for each of these equations. Alright, so now let's go through each of these together. So I'm just going to mention that you definitely can use exact values to find the angles because all of these are exact values. So if you use exact values, that's perfectly fine. But since we are talking about inverse trig functions in this video, that's the method I'm going to be using. Okay, so let's begin with the first one. So we have cosine theta is equal to square root of 3 over 2. So the first step is you take inverse cosine of both sides. So you take inverse cosine of both sides. Okay, and then inverse cosine and cosine cancels. So you take cosine is equal to this. So you can just put this into your calculator, and again, make sure that it's in radians. And if you put it in calculator, you should get theta is equal to pi over 6. So now you have to check, make sure that this is in our like range, right? So remember that the range for cosine, and if you don't remember, it's fine, just build it, is from 0 to pi. And so pi over 6 falls in this range, so we're good. And honestly, you don't even have to check because the calculators automatically give you the principal value. But it's good just to check, just like in case, because sometimes it's you can just check if you want. It's whatever. Anyway, moving on to the next one. So we have cosecant theta equals negative 2 root 3 over 3. So again, first you have to take inverse cosine, or inverse cosecant, I mean, of both sides. And then inverse cosecant and cosecant cancel, so you're just left with theta. And you could just put this into your calculator, and you should get negative pi over 3. Alright. And then last one, we have cotangent theta equals negative square root of 3. So first step, we have to take inverse cotangent of both sides. Okay, and then inverse cotangent and cotangent cancel, so you're just left with theta, and then put this into your calculator, and you should get negative pi over 6. Okay, so that's just some like basic examples of how to use inverse trig functions. Alright, so now let's do one more example. This one's a little bit more interesting, in my opinion. Alright. So essentially, let's just say you have some students. So let's say a student is standing at the top of 100. At the top of a 201-foot cliff. Okay, and then he sees a lighthouse 430 feet from shore. Right, so you want to find the angle of depression. Find the angle of depression from the student to the lighthouse. Alright, so this is a pretty cool little word problem that we have here. So the first step with these types of word problems, especially that we're in trig, is we have to draw a picture, right? Because pictures are going to help a bunch. So let's draw a picture. Okay, so essentially, let's say this is the top of the cliff right here. And so that means that the height of the cliff is 201 feet. So this length right here is 201 feet. And then we'll say the lighthouse is over here. So we know that the lighthouse is 430 feet away from the shore. So that's this, if this is the shore, this is the lighthouse, that means that this length right here is 430 feet. Okay, and so we know the student is standing here, the lighthouse is right here, so you want to draw like a little lighthouse. Not that good at drawing, but we could just like draw a little lighthouse right here. Okay, and then we have like the little student, right? He's like right there. Okay, so we want to find the angle of depression. So first of all, what is the angle of depression? So that's like we're gonna make a horizontal right here, and the angle of depression is this angle right here. So this angle right here is the angle of depression. I'll say that we'll call it beta, and I'm also gonna label this angle inside as alpha. Okay, so our goal is to find beta. So first of all, let's just examine angle alpha, right? So for angle alpha, notice that we're given the opposite side for angle alpha and the adjacent side for angle alpha, because this is the hypotenuse, but we're not given the hypotenuse. So what trig function relates the opposite side of an angle and the adjacent side of an angle? Tangent theta, right? So if we take tangent alpha, we know that's going to equal the opposite over the adjacent side. So that's going to equal 430 over 201. Okay, so now we don't want alpha, right? We want beta. So let's try writing alpha in terms of beta. So we know that this whole angle right here, this is a right angle. Okay, and so that means that beta is equal to the right angle, which is 90 degrees, minus alpha. So alpha is just equal to, or I'll say beta. Beta is just equal to 90 minus alpha. Okay, so we could substitute that in for alpha then. So solving for alpha, we get that alpha is equal to 90 minus beta. So substitute that in, so we get tangent of 90 degrees minus beta is equal to 430 over 201. And now this is a classic inverse trig problem. So first thing is you could just take inverse trig of both sides, or you could simplify the fraction, up to you. But I'm going to take inverse trig of both sides, inverse tangent, I mean. Okay, so then inverse tangent and tangent are going to cancel. And then you get 90 degrees minus beta is equal to inverse tangent of 430 over 201. So notice that in this problem we're in degrees. So before putting this into your calculator, convert to degree mode first, and then put in a calculator. And then once you get some value for this, let's see, you could just take 90 minus that, and so then overall you get beta is equal to 25.053 degrees. So that is the angle of depression. Alright, so you just take inverse tangent and then you isolate beta, solve for beta, and then you get this. Alright, so yeah. But that's pretty much it for inverse trig functions. If you enjoyed this video, please make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.